Imagine our solar system is like a giant cosmic dance floor, where all the planets are spinning in the same direction, a bit like figure skaters all doing a counterclockwise twirl. Now picture Venus waltzing in, but it's spinning the opposite way. That's right. On Venus, the sun rises in the west and sets in the east. This backward spin is called retrograde rotation, and it makes Venus a real standout in our celestial neighborhood. While Earth and most of our planetary pals spin like tops in one direction, Venus decided to be different. It's a cosmic rebel, and that's what makes it so fascinating to study. This strange rotation isn't just a fun fact. It completely changes what a day or a year would feel like on this world. The weirdness doesn't stop there. A day on Venus is longer than its year. Think about that for a moment. It takes Venus about 225 Earth days to complete one trip around the Sun. That's its year. But it takes a whopping 243 Earth days for it to finish just one single spin on its axis. This means, if you could somehow stand on its scorching hot surface, you'd see the sun rise, but you'd have to wait for what feels like an eternity for it to set again. You would celebrate your birthday before the day was even over. This super slow backward spin makes Venus one of the most peculiar places in our entire solar system, a planet where time itself seems to move in a truly unique and unhurried way. So, why does Venus spin backwards? The leading theory is a story of cosmic violence. Billions of years ago, when the solar system was a much messier place, scientists believe a huge planet-sized object might have slammed into Venus. This wasn't just a fender bender, it was a catastrophic collision so powerful that it could have completely flipped Venus upside down, or, more likely, knocked it so hard that it reversed its original spin. Imagine spinning a basketball, and then someone smacks it from the side. It might wobble and then start spinning the other way. That's essentially what we think happened to Venus, a dramatic event that forever changed its dance. Despite its bizarre spin, Venus is often called Earth's twin. This isn't because it's a nice place to live, far from it. With surface temperatures hot enough to melt lead, and a thick, crushing atmosphere of sulfuric acid clouds, it's more like an evil twin. The nickname comes from its similar size and composition. Both planets are rocky and roughly the same mass, but that's where the family resemblance ends. Venus is a cautionary tale of what can happen when a planet's climate goes horribly wrong, making us appreciate our own spinning blue marble all the more. Its backward slow day is just one more feature that separates our twin from us. To understand why Venus is so weird, we have to go back in time, way back, about 4.5 billion years. Before the planets, there was just a gigantic spinning cloud of gas and dust floating in space. As this massive cloud began to collapse under its own gravity, it started to spin faster and faster. Think of an ice skater pulling their arms in to speed up their spin. This is a cool science principle called the conservation of angular momentum. As the cloud spun faster, it flattened out into a huge disk, like a spinning pizza dough. At the very center of this disk, where most of the material gathered, our sun ignited and came to life. All the leftover dust and gas in that spinning disk didn't just disappear. Instead, tiny particles started sticking together, a bit like dust bunnies under your bed. These clumps grew bigger and bigger, first becoming pebbles, then rocks, then boulders, and eventually, they formed the planets we know and love today. Because they were born from this swirling, spinning disk, the planets inherited that motion. They were already spinning from the moment they were formed. This is why most planets, including our Earth, all orbit the Sun and spin on their axes in the same counterclockwise direction. It's a family trait, passed down from that original cosmic cloud. Of course, the process wasn't perfectly neat. As these baby planets, or proto-planets, grew, they were constantly bumping into each other. These weren't gentle taps. They were colossal impacts that could reshape a world. Each collision could change a planet's spin, either speeding it up, slowing it down, or even knocking it off its axis. This early chaotic period of the solar system was like a cosmic game of billiards, where every strike had a consequence. The way a planet spins today is a direct result of all these ancient impacts, and the original momentum it got from the solar nebula. So, the default setting for a planet is to spin in the same direction as the disk it came from. Jupiter, for example, is a great showcase of this inherited spin. It's the fastest spinning planet in our solar system, completing a day in less than 10 hours. Its rapid rotation is a powerful reminder of the immense energy contained within that primordial cloud. But as we've seen with Venus, and as we'll see with others, this default setting can be dramatically altered by later events. The story of planetary spin is a tale of both orderly formation and chaotic, world-changing collisions. Venus isn't the only planet with a peculiar spin. Take a look at Uranus, the seventh planet from the Sun. While other planets spin like tops, Uranus rolls like a bowling ball. It's tilted on its side by an incredible 98 degrees. This means its poles are where most planets have their equators. Just like Venus, the most likely explanation for this extreme tilt is a giant impact from another large celestial body billions of years ago. This sideways orientation gives Uranus the most extreme seasons in the solar system. For decades at a time, one pole faces the sun in constant daylight, while the other is plunged into a long, dark, and freezing winter. Then there's the phenomenon of being tidally locked. This happens when a moon orbits so close to its planet that the planet's gravity grabs onto it and slows its rotation down until it matches its orbital period. The result? The moon always shows the same face to its planet. Our very own moon is tidally locked to Earth, which is why we always see the man in the moon and never its far side, often mistakenly called the dark side. It's not always dark. It gets just as much sunlight as the side we see, we just can't view it from here. It's like a dancer who is always facing their partner as they circle around them on the dance floor. This gravitational dance can get even more interesting. Take Pluto and its largest moon, Charon. They are so close in size and proximity that they are mutually tidally locked. This means that not only does Charon always show the same face to Pluto, but Pluto also always shows the same face to Charon. If you were standing on one side of Pluto, Charon would hang motionless in the sky, never rising or setting. If you were on the opposite side of Pluto, you would never see Charon at all. They are locked in a permanent, face-to-face, cosmic stare-down, as they orbit a common point in space between them. And sometimes, rotation isn't neat or predictable at all, it's just plain chaotic. Some of the smaller moons in our solar system, like Saturn's moon Hyperion, don't have a stable spin. Their rotation tumbles and changes unpredictably over time. This is because they are often oddly shaped, like a potato, and are constantly being tugged on by the gravity of their massive parent planet and other nearby moons. Imagine trying to spin a lumpy rock. It wouldn't spin smoothly, but would tumble end over end. That's chaotic rotation, and it shows that in space, even the simple act of spinning can be wonderfully complex. The spinning doesn't stop with planets and moons. Even our star, the Sun, rotates on its axis. But here's the cool part. The Sun is not a solid object. It's a giant ball of super hot gas or plasma. Because of this, it doesn't spin like a solid rock. Instead, it experiences something called differential rotation. This means different parts of the Sun rotate at different speeds. The Sun's equator spins the fastest, completing a rotation in about 25 Earth days. However, its poles are much slower, taking around 35 days to make one full turn. It's a spinning, stretching, and churning ball of plasma. This differential rotation is incredibly important because it's what drives the Sun's powerful magnetic field. As the Sun's equator outpaces its poles, the magnetic field lines get twisted and tangled up. Think of it like twisting a rubber band until it's full of knots. Eventually, these tangled magnetic lines can snap and release massive bursts of energy. These events create awe-inspiring phenomena like sunspots, which are cooler, darker areas on the Sun's surface, and solar flares, which are colossal explosions that hurl radiation and charged particles out into space. So, the Sun's weird spin is directly responsible for its dynamic and sometimes stormy weather. This principle of differential rotation isn't unique to our Sun. It's common in other stars, and even in the gas giant planets like Jupiter and Saturn. Jupiter's fast spin and fluid nature mean its equator also rotates faster than its polar regions. This shearing motion is what creates the planet's famous colorful bands and a storm that has been raging for centuries, the Great Red Spot. The way an object spins, whether it's a solid rock, a ball of gas, or a star, tells us so much about its composition, its history, and the powerful forces that govern its behavior. From the backward spin of Venus to the sideways tumble of Uranus and the differential rotation of our very own sun, our solar system is filled with amazing examples of cosmic motion. Each planet, moon, and star has its own unique spin on, well, spinning. These quirks aren't just random oddities, they are clues that help us piece together the dramatic 4.5 billion-year-old story of how our solar system came to be. So next time you look up at the sky, remember that you're standing on a spinning planet in a swirling solar system, where everything is in constant, beautiful motion.